So what is a spook in the shell? Oh, by the way, I'm really ill right now. I was ill. I was in bed all day yesterday, and with a fever and sweating, and I'm still quite ill. So I might apologize for that. But I know you guys had a talk on empathy earlier today, so you can give me some empathy here. So what is it? It's a shell script compiler. You get this like Perl 6 like language here, and it compiles into a shell script, which does the thing you wrote. Okay, that's exactly, okay, so I gotta stop using my mouse. We're back. Okay, I'm not gonna use my mouse anymore. Okay, so spook, it's a backronym. A backronym is where you take a word that already it's a normal word and you make an acronym out of it, but it's actually a backwards backronym. So it's like a backronym for compile time only operations Perl 6. So you want to write Perl 6, but the place where you want to run it doesn't have a Perl 6 interpreter or anything like that. So you compile it out to a shell script so you can do like operations on remote machines, like install packages and so on and so forth. Spit is the compiler, which is just taking the letters out of that and making an acronym. It spits out shell. It's like a camel, so it has that Perl linked back there. Camels spit a lot. And it means that I can call the specification suite spit roast. So that's the puns I have. It's actually pretty huge. I've been working on it for like a year and a half at least, and it's 10,000 lines of code. It's got 1,400 spec tests. Put that in perspective, Rakudo is like 50,000, 60,000, something like that.
It's close to 70 now.
70,000. So to put that in perspective, it's 1/70th the size of Rakudo. But I looked at Moose. I guess you guys are familiar with. Moose is like 800 spec tests. So it's somewhere between Moose and Rakudo. Why would you do this? Shell scripts are terrible and DevOps tools are also terrible. But maybe if we make a DevOps tool out of a shell scripts, it will be okay. This is a philosophy I have called configuration as a shell script. And it means you just try and use the inbuilt Unix tools to do configuration rather than having like a remote interpreter or a daemon like Puppet or Chef or like having a Python interpreter there interpreting things over SSH like Ansible. You just make a shell script and that way you can just get the shell script over there and run it. So it's postmodern because it doesn't do what the modern tools do, basically. It tries to revitalize the old Unix tools. And it's also postmodern because Larry wrote Perl to get away from shell a bit and wrote Perl 6 to get away from Perl 5 a bit. And I'm using Perl 6 to make shell scripts. So it's like the whole postmodern progression. And so the philosophy is this, the idea is this: can the operations you want to perform on your systems be reduced to a list of shell commands? And let's just produce the list of shell commands and do that. You can pretty much do anything with shell commands. You can create Docker images, create virtual machines, consume JSON APIs, install packages, inspect machine state, modify configuration, and you can create like certificates. I guess you guys know about like Let's Encrypt and stuff. The way most people do Let's Encrypt is with a giant shell script. So I think you can pretty much do anything useful in terms of operations in shell scripts. You don't need a Python interpreter or a Perl interpreter there. You can just write shell scripts. What you can't do with shell is like create an iOS app, create a website, or like a VR game. It's not going to happen. So what's wrong with shell itself? There's so many gotchas. It's really difficult to handle failure. Difficult to make libraries. There's no compile time checking of anything, and they're not really portable unless you really know what you're doing. And now that I do know what I'm doing, I tell you, you don't want to go through what I've been through. So So let's describe our procedures in a Perl 6-like language and compile it out. Let's have modules, type checking, function signatures, classes and methods, regexes, and testing frameworks. It's basically TypeScript for bin.sh. How? You write a compiler in Recrudo. You pass it. You pass the language with Perl 6 grammars. You build up an abstract syntax tree, and you compile the abstract syntax tree into shell. It's the first 2 bits are what Perl 6 does, Recrudo does already. Just the last bit changes. And before I started this, I didn't know anything about compilers or writing compilers or anything like that. And so I basically made up all my own nomenclature. So if I start talking about things that don't make any sense in terms of compilers, don't worry. But this is the different stages. You have the pass stage, which is similar to how Recrudo has it. You just tokenize everything. Then you have the abstract syntax tree stage, where you get a basic abstract syntax tree. This is just for, say, 1 + 1. Then in the second stage, you do the type checking, where I call it the context propagation stage, where each expression or each abstract syntax tree node tells its child nodes what context they're in, what type context they're in. So in this case, it's 1 + foo. The plus expression is telling its children, which is 1 and foo, that they're both in int context, so you get an error. This is the third stage, which is the composition stage, which means you've got say 1 + 1, but say requires the definition of say, right? It needs the declaration of that function in the shell script. So the composition stage pulls everything in. It also does the optimization. So the 1 + 1 is actually changed into a 2. Never mind about all the other noise in that. And in the end, what you get is that. So why would you actually do this? It has been a lot of suffering writing a compiler when I didn't even start out intending to write a compiler. But I sort of got sucked into it, and I got addicted to it, really. But the real use case for it, other than being pathological, is to create shell scripts for all these little places you can put shell scripts. Like, Debian preseq. When you boot up a Debian machine, bare metal, maybe on TFTP, you can run a little shell script at the end. You can curl shell scripts to SH. You can put in many of the VPSs. Nowadays, you have like this cloud init thing, which can run a shell script at startup. You have like Docker images and stuff. You can SSH and run shell scripts over this. So there's so many different places you can put shell scripts. I thought that creating a compiler to do that work rather than writing the shell script yourself, so you can make them reusable and testable, was a cool idea. So I'm just going to try and explain the differences and how the language really works, the difference between this and Perl 6. So everything is a string in the shell, but we can attach some meanings to strings. So you got like a file here, /etc hosts, which means you can call methods on it. You got GitHub, like a GitHub repo, which means you can call the method latest release URL to get the URL to the latest release. This is a list of files. Just like in Perl 6, you put the word quoting angle brackets and put a space, you get a list. So you got a list of files and you can iterate over them. So this is what it actually compiles out to, is that you get stat, which is the best way to find the owner of a file, and you get that, and actually got inlined. So the composition phase actually inlined the definition of that method into the call. So then you got the latest release URL, which didn't get inlined because it was too complicated to inline, and then that's what the for loop roughly compiles out to. Yeah. That's what it actually looks like. So this is just the main, right? This is the entire script. That's the main down there. Because the reason for that is in order to do this latest release URL, you need to have curl. It means you need to install it, which means you need all the stuff in the shell script to check if curl is installed or not. And the main thing is checking when the last time apt-get was updated, or APK, the last time the package list, and if it was too old, update it. So that's why there's all this other stuff in there. But if you, for example, compile it for CentOS, which you do with the --os flag, it becomes a lot smaller because CentOS already has curl installed, and it knows the differences between the different platforms. Well, technically, it's only CentOS, Red Hat, roughly, and Alpine, and Debian that actually works for. Okay, so do I risk running this? Okay, I'm gonna try. Bear with me. There you go. That's the shell script for Alpine. So what I'm going to do is I'm going to run it in a Docker image, the Alpine Docker image. So it installed curl, and that happened pretty quick. And I guess the internet's good here. And you can see this is the latest release URL for JQ. These are the last modified times for the bin and user bin. And the owner of /etc host is root. Now what I can do is show you something here. I'll show you the logging, because that's kind of, the output there isn't that interesting. So I tried to built in logging, which is also another thing you can't really do well from shell scripts. So here we go. So you get these cool emojis, and this is an info level log. And it's a spook, which just means that it's not from any application in particular. It's just telling you that it's installing curl. And now, this is from the package manager, which is APK in this case. It's got a cool package emoji. Installs it, and then, so that just gives you a little bit more idea what's going on if you turn logging on. Let's go. Let's continue. So, this is how you do shell commands. You do $curlies, and you write the shell command in it. You can interpolate variables in there. You can like call it like a method call syntax. So you call the shell command on an object or on a value that's there, and that actually pipes it in. So if you want to pipe a value you have into a shell command, you can just use a method call like thing. You can just do normal things like piping in them as well, and input redirection, and that gives you this. So we have object-oriented shell now. So this is how you declare a class, and you see that first thing to notice is that you have different definitions for different operating systems. So Alpine, this is how you do it, add a user. On GNU, on any GNU, which means Debian, Red Hat, it's all like you can be as specific as you need to be. But GNU systems, you can do it like that. Deleting Red Hat is a special snowflake, and anything else you can do it like delete it. You can delete it like that. Other things is you can. These got name parameters. This is method routines, like functions have mandatory return types in Spook and the shell. So you've got the question mark is shorthand for returns a Boolean. So they both return delete and exists returns Boolean. So you want to create a new user, you just say user is like LL Fawn, and then dot create, and then like that. So no, that's wrong. So that compiles down to that. Should be roughly straightforward. So there's some type checking. So it's only done. The fundamental type is the string type because everything is inherits from the string type. Type checking is only done at compile time, obviously, because it's difficult to put type checking into shell scripts. Only primitive type checking is implemented, and I'm going to explain what that is. So you make the type variable A as an integer, then you assign it to a file, and that will fail. It will give you this error because you've already said it's an integer. But if you assign it to a PID, which is a process ID, it's going to be fine because a PID is an integer. But that int there is actually completely superfluous because when you assign, if you did my $A is equal to 1, that's already an int then. It's already an int from then on. You can't go if you wanted to say it was the string 1, you would have to put quotes around it. As soon as you assign it to something, it just inherits whatever the type is on the right-hand side in the declaration. And so the reason it works is because you have primitive types. So the primitive of int is int, primitive file is a string, and the primitive of a PID is an int. So that's how you determine what's compatible and not compatible. It works pretty well, except it doesn't cover every kind of constraint you'd want that you could do at compile time. But that's as good as it gets for now. The only thing to know about variables is you actually got lexical scoping. So you got my A is equal to foo, and then in another lexical scope, you got my A is equal to something else. And you can see that they're two different variables, and it knows about lexical scoping. And the only other type of variable is a constant that, as you can see, what happens here, it gets inlined. It gets inlined. So because it's known at compile time, it just gets inlined. You've also got options, which have this twidgel here, which is confusing maybe if you know what it does in Perl 6, but you don't. But it does something a little bit different. You declare variables like that. And what that means is you can customize what that value is going to be. So basically, this just makes an option foo with the default of bar. But when you're compiling it, you can say option foo equals baz, and that's going to compile say baz there. So that say is compiling to bar when there's no option pass. When you pass an actual value for the option, it changes to baz. So I've implemented a lot of stuff, a lot of the Perl 6 stuff you would expect. So you got normal positional parameters, you got optional positional parameters, you got positional parameters with defaults, and you've got name parameters and name parameters with defaults. I haven't yet got required name parameters, but I'm sure I'll get to that eventually. So you can see down here what happens is name parameters are actually passed as like environment variables, whereas positional parameters, it uses the $1, $2, and so on. Even have Slurpees. So that does what you might expect. The positional parameters before the Slurpee get assigned to the one and like the numbered dollar variables. Then it shifts them off, and then you use like the $* and $ampersand, no, $@ for the value of the Slurpee. And you can actually have type Slurpees, which you can't do in Rakudo. So you have type Slurpees, and that'll do the type checking for you. You can see you've got a range here, We've got some numbers. It actually, and it uses sec obviously for ranges. It actually works. Yeah, you got return types. So as I said, they're mandatory. If you don't put a return type, it doesn't return anything. And that'll lead to an error if you try to use it as a value anywhere. So this is the shorthand for returns a string. This is shorthand returns an int. This is shorthand returns a boolean. And then if you, the longhand is return this syntax, the Perl 6 syntax. The only difference is that you don't put it inside the signature. You put it outside. I preferred that in the end. Now, eval. So eval is probably the most important construct in all of Spook in the shell. So it creates an embedded shell script within your shell script. You can pass eval different options that you have than you have to the outer shell script. You can interpolate runtime values that the outer shell script has into the inner shell script, and it can get pretty spicy. So what happens actually is so it's saying script equals eval say hello world, which means we're getting the script as a value. You see what happens is you have a cat with a here doc delimited by cat emojis, which I think is funny. That's the height of my humor, right, in this talk, so you should laugh at that one. So yeah, so you have this embedded shell script, and you have it as a variable. This means you can send it to other places, use it in other later date or whatever. So, example where you use this, you want to do something inside a Docker container. So I don't know how many people know about Docker. I know there's a couple of Docker talks on, maybe all the Docker people at the Docker talk, but I use Docker quite a lot. What you can do then is say, okay, so Docker lets you execute a shell script inside a container. So you eval, you have to tell the operating system, which is at the moment it doesn't know how to guess, and you write the spook code inside, and it will compile the shell script, and that'll execute it. So that looks like that. You have different cats. But yeah, so you can see this one is the Red Hat one, the CentOS one, and this one is the Debian one. Oh, and we're doing cleanup here. Cleanup just means deleted at the end, so we're doing it temporary. So at the end, you have this end. You actually have an end phaser, which I'll just mention briefly. But you can run things at the end, which actually does things at the end of the shell script. And it'll run if it gets terminated or whatever. Okay, yeah, let's run it. Still have that thing there, all right. Copy that. All right. Let's check that it worked. Yeah, false. That says false and true. You can see it there. So that's true. So curl does not exist on Debian by default, and it does on CentOS by default. That's why it's false and true. Okay, so the future. I want to put multi-dispatch in it. Right now you have a kind of multi-dispatch on operating systems, but you don't have multi-dispatch on like signatures, which is kind of annoying. And it's not like you're not getting the value you get from Recruito's multi-dispatch because that's done at actual runtime. You're getting you're able to use the same name for different methods that do different things depending on the parameters. Macros, which would be really useful. Because if you have a compile time language, I think macros are even more useful than they would be in Recruito. Better module support, regex replacing, and async and promises. I know it might sound even more crazy to put promises inside shell scripts, but I think I have a good idea how to do it, and I think it would be pretty awesome, actually. So yeah, and I bought the domain spit.sh, and what I want it to be is like a thing where you can put a configuration and you can just curl it. It'll produce the configuration dynamically. You can pass it options, and it will dynamically produce the shell script for you, and you can just curl it into your shell. I know some people find curl to sh distasteful, but I think it's pretty awesome. There are a lot of rough edges. It's not ready for production unless you're trying to produce cat emojis and fun. But if you're trying to actually do work, it's not ready for production. I've still got this problem, the subshell problem, which means that when you have a shell script and a lot of the things that run in subshells, especially when they're on the right-hand side of any assignment. So sometimes you have side effects within those subshells that then they don't make it back to the outer script, the mainline shell script, let's say. And I haven't completely solved this problem. I think the main solution is just to warn you or make an error when you've got a subshell problem. You can probably tell when you're going to have one, or just more compiler tricks to avoid subshells in as many places as possible. Yeah, I think. Okay, I actually missed out a point because I just realized that. Back to eval. Just back to eval. So this is the runtime interpolation of variables in an eval. Okay, so this eval script obviously is another shell script, and in this case we're just piping it into sh. What happens here is Spook in the shell can tell that these variables were runtime variables. They're not defined in this shell script. So what it does is it takes these runtime variables and it substitutes them back into the inner shell script. So it can see, so they get assigned to flower and love heart emojis here, right? But this is just like a template shell script. And so what it does is then it substitutes them. So it takes the value of 1 and it substitutes these little flowers here, and takes these love hearts and substitutes the value of 3 and this flower, and substitutes the value of 2. And that's how you get these run. You can take values you have at runtime and put them into shell scripts that are embedded inside. And I'm going to do something with that interesting in a sec. So I just realized I forgot that bit. Yeah. So now I'm gonna do this demo. This is. Does anyone know what Twilio? People know what Twilio is? It's a thing that you can send SMSs. And I guess most people know what DigitalOcean is. So it's a VPS. So I'm going to do this kind of completely pointless demo. But what this is, so I made this class Twilio. You can see you have this. This is how you would use options. You need your auth token, and you got is required. So if you actually use it and you didn't pass it in, it's going to throw an error. So you got your account SID, your API, and where the SMS should be coming from. I've just got one static method. In Spook, you have to declare static, whereas in Perl 6, you don't normally declare things as static. You have to in Spook because it's really difficult to tell. You have to know at compile time whether something is static or not static. So you can send an SMS. The default from is the from option, and then to, and you get the message. And what this does, so this HTTP is another class in Spook. You've got, so this is the URL, the API URL, and you can make a request. And it's pretty full-featured HTTP user agent I've built in it. So this is the form, right? So from to body. So it's not a JSON API in this case. It's just whatever you call it, a post form. So that's that bit. Then what we're going to do is use this class. I'm going to send it to my number here. This is my Dutch number I bought recently. And we're going to create a DigitalOcean virtual machine called a droplet. And what this create SSH seeded thing does, it's the thing I invented, but when you create a new virtual machine, normally when you try to SSH into it first time, it asks you that question, like, do you want to accept this SSH certificate? You guys know about that, right? And you guys click yes, right? Yeah. Yeah, well, you have to. There's basically no way around it. Except what I've done is, so because you can just, Spook allows you to compile shell scripts, you can write a shell script that runs at boot time. And what I do is this create SSH seeded. It actually seeds the SSH public key and private key into the virtual machine, so I know what I can trust before I start SSHing into it, which I think is pretty handy. And like, I tried to sort of see if you could do this in Ansible, and I couldn't do it in Ansible. It took me like too long a time to actually get this to work. I could create virtual machines, DigitalOcean droplets in Ansible, but then I had to do something else, and it wasn't able to quite get it right. I'm sure there is a way, but other tools didn't seem so easy to do this. So I think it's pretty cool. And then we're going to SSH into it. And what this seeding SSH, it doesn't change the certificates for the public key, rather the public key private key pair for the normal SSH on port 22. It just runs another SSHD on port 22222. So we're going to SSH into that, and we're going to run this script, which is the send SMS. And so and then at the end, we're going to delete the droplet. So all this is doing, it's totally pointless, but we're creating a DigitalOcean droplet. We're SSHing into it and sending myself an SMS from inside the droplet, which means just making a curl request. So here you go. Go. I think I might need to zoom in. Oopsie daisies. Okay. So here we go. So the ocean is DigitalOcean. This is HTTP requests. And so it's waiting now for the droplet to boot the virtual machine.
It's waiting, so it's watting.
Did I miss what?
Something.
Oh, I watting. Yeah, okay, so that's a misspell. That's down to me. Okay, so now it's active. So now it's just waiting for the script to run that starts the SSH on port 2222. That did. You can see now our SSH, and this is the package manager on the virtual machine. So, and you can see it's got the puffy fish. That's the emoji for SSH. Luckily, the Unicode team decided to add a pufferfish. So just installing stuff. I chose the Amsterdam region, so hopefully this will be okay. Seems to be stopped right now. Right. Normally this should be fast. You know, apt get installed. Oh, there it goes. So it's installing curl right now. That's basically what it's doing. Just an apt-get install curl, basically. That's taking a long time. But you know, this is the kind of stuff that happens when you're creating virtual machines and you're doing VPSs. It just doesn't work all the same each time. It's kind of weird. But it keeps going. By the way, this logging stuff, it's actually all done in shell. Like, it's not Perl 6 interpreting the shell's output and then putting stuff on it. It's all done in the shell. It's some stuff with sed and awk, and it like reads output and just puts the emojis and timestamp in front of it. Okay, it seems to be getting there. So that was just updating. Now it's actually installing Perl. It's doing it. Okay, that goes. Yeah. Okay. Okay. So it made HTTP request to Twilio, and I believe I just got an SMS. Hey. Oh, what? And yeah, I think the SMS was. didn't mention it, but it's sending the Debian version. So I got 9.1. Okay, so.
One minute, you can just use this to point it on the screen.
Okay.
Yeah, backside.
That's all good because that's the end of my slides.
Okay.
Now it's all demos and stuff.
Okay.
So yeah.
You were pointing it on the screen.
Oh, yeah. Okay, I'll take that. I like gadgets. I'll take that thing.
Backside.
Okay, the backside.
Yeah.
Yeah. Okay, that's good. Okay. So that's the end of the main part of my talk. But I have more stuff to show you, so I'm going to do that with this thing. Okay, so how did I run that? Yeah, so this is -H. That -H is running in the spit. I call it the spit helper image. It's a Docker image that I created specifically for running stuff in. So it has curl already installed. It has JQ already installed, so you interact with JSON stuff. And by the way, there's pretty good JSON support in Spit. It's kind of funny, but I did a lot of work to make sure you could interact with JSON APIs really easily. That's how the DigitalOcean API is implemented. It takes quite a lot of work, but it does work. Yeah, this H is the Spit helper image, which means, and what I'm going to do is just show you how that's built, and so we can see some more Docker stuff. So I'm going to go. You do that. You Spit helper build. So what it's going to do is now build the helper image. So you can see this is the whale. The whale is Docker, right? Well, that was super fast. Oh, no, right, we're using this now. Okay. So
5 minutes.
Sure. So this is the Docker. And so what's happening is this is the Spit helper image, and now it's just running stuff inside here. So maybe we can just go back up a bit. So you can see. So what all this Spit helper thing is doing is it's creating a Docker container, and inside it, the Docker Spit helper builder, and then inside it, it is installing some stuff. In particular, it's got curl. It's got Docker. So this is Docker inside Docker, okay? And it's got Git and JQ and SSH and SOCAT. And probably more things in the future. And then it commits it at the end. So I got pretty good Docker support. I haven't really showed it, although I think I said I was going to do that. But I did it. So that's basically it. I do have one more spicy demo for you guys. But I checked it before this, and it didn't work. It actually failed. But that's okay. We're going to see what Spit looks like when it's failing. If I had more, like if I had 2 hours, I'd probably show you 1 hour of it failing, because you can fail, obviously, with this kind of thing. So it's Spit. What is the name of it? Test Squid. Okay, so what this is going to try and do. You guys know the proxy Squid, right? So it's going to try and create a droplet, install Squid on it. Then it's going to create 2 more droplets. Actually, it's going to create 3 droplets, okay? So one's going to have Squid on it. The other one is going to be in the Squid one, it's going to have one IP address that's going to be allowed to use it. That's going to be one of the Docker, that's going to be one of the DigitalOcean, that's going to be one of the DigitalOcean droplets. And the other one's going to be not allowed. So what it's going to do, it's going to test the Squid module that I've written by installing Squid and then testing that the allowed IP is allowed to make requests through it, and then disallowed IP is not allowed to make requests through it. So, and it didn't work when I just tried it, but let's go. Okay, and this may take up all my time, so maybe it's a good time for questions while this runs. Is there any questions?
Do you have something like Ansible has, like gathering defects?
No. Oh, I have to run that, so whoopsies. I don't have something like that. Basically, obviously, you could manually do it, right? So you can SSH into a thing, and then you can, if you have an IP address, like which is another class in Spit, you can SSH into it and run a script, and that can return stuff.
Yeah, but this can help like, for your whole system. I mean, you can not strictly define the operational system like Debian or CentOS. You can just get the fact like, is apt-get available and we can use this and we are using this and so on. I mean, there are a lot of operational systems which have a lot of common.
I think, yeah. So I think what you're pointing out is that Spit is not even really a DevOps tool. It's actually just a shell script compiler. That's all it does. It just compiles shell scripts. And you can use it as a library. So what you could do is actually write something like Ansible that in Perl 6 that uses Spit as a library and does that kind of thing where it already knows, like it already goes to the virtual machine you're trying to manage, already knows its operating system, and then uses Spit to compile something. If you get what I mean, yeah. Okay, where's this at? So it's okay. This is very noisy because now it's got three virtual machines all installing crap. Okay, so it's restarting Squid now. See that? Whoop! More stuff's happening. So yeah, you can change the log level. I might show you that in a sec. Now it's waiting for the Squid port to open. Go ahead.
Can you change the emojis to something that's more easily parsable than something that doesn't understand emojis?
Oh, I have to repeat the questions. Oh, the first question was, do you have something to gather facts about the remote machines before you go and create a shell script for them? Now, the second question is, do you have, for people who dislike emojis or for technical reasons, you don't want emojis in your logs because you're trying to parse them, do you have some way of disabling emojis or putting something else in place of the emoji? And the answer is no, not yet. It's just for fun, basically, at the moment. But yeah, I think that's definitely something I absolutely need to do. Okay, hey, it worked. So, and you can see the squid is obviously a squid emoji. But you can see that's a squid access log. That's this. So what happened was this dude here. So they both were able. These two different IPs. They both were able to connect. This one was able to make a request. And this one yeah. So this guy made a request. It was fine. Where's the one that failed? And see.
1.3 there somewhere. There it is.
Yeah, this guy couldn't make a request. So that's actually tested it properly. You know, like if you look at the modules like for Puppet or like Ansible for testing Squid, the Squid modules, they don't really test it, really, so to speak. They don't actually create a bunch of stuff and test that it can actually works through making several virtual machines. Sort of like that's left up. You either don't test it or it's left up to a task for the user. But in Spit, you could theoretically, you can write modules that actually create virtual machines and do tests on remote systems with several virtual machines. That's what I think its advantage is. And with that, I will leave it there. Thank you very much.